Exploit blockchain.
John McAfee's company kind of came up with this, and it's typical John McAfee. It kind of got a whole lot of hype and stuff, and probably a bit of dubious claims. But this claim was actually made by another guy, Salem Rushdie, and he took one of these wallets, he pulled the back off, and he got it to go play Doom. You know, you might remember Doom, the old PC game where you go shoot at various monsters. I used to go play it when I was a kid myself, and this got a lot of press. You know, a whole bunch of articles saying, well, you know, the wallet's hacked, et cetera, and I got to think to myself, you know, this isn't quite right. I mean, kind of concerned me that people were conflating installing your own software on your own hardware hacking. Because after all, once you open up the back of a device, I mean, why shouldn't you be able to go install what you want on it? I mean, that's why we have open source in the first place. You know, this is why we have all these freedoms and stuff. And I thought this was a real issue, that they were kind of conflating these two. And I kind of said this, and got a bit of attention, and I don't think the guys who were hacking Bitfee really liked this. Here's one of their responses to it. And essentially, you know, they were kind of saying, well, you know, they could do what they wanted and so on, and it kind of ended up in a bit of a mess. And I thought, you know, it'd be a good opportunity, maybe explain a bit. Well, what does it really mean for a hardware wallet to be secure? You know, is it okay? Is it a part of the threat model to take the back off and install Doom? And finally, I'll give maybe a bit of a disclaimer as part of this silly Twitterness. That's the CTO of Trezor Wallet giving his opinion on whether or not you think you should go listen to this talk. The point I would make is really, don't listen to me because I'm some guy who gets introduced in that fashion. Let me convince you that something's true, rather than just taking it blindly. So I kind of agree with him, actually. Although, I'm still going to give the talk. There we go. So, let's look at the status quo. You know, if I don't have a hardware wallet, what kind of wallet am I using? In this example, as a demo, I've got Electrum. It's running on my laptop. And I've got the main page. And I show this because it's always good to remind people, what are you actually seeing when you go use a wallet? You know, what is the actual interface? It's not some abstract thing. It's, you know, an actual physical device that you're looking at. And it's a device you're interacting with. And for reference, here's the Electrum page. You know, simple enough. It's got send, it's got receive, and so on. And we can kind of go ask, well, you know, what can go wrong, right? And apparently, the slides can go wrong. But what that should go say is you've got theft, interception, and screw-ups. And maybe a fourth category, slides getting screwed up. And let's go through them. I mean, first of all, what does it mean by theft, right? I could have a Bitcoin wallet, and the bad guys could get my private keys. And once they get my private keys, they can take all my Bitcoin. Seems simple enough. Interception is a bit more subtle. When I talk about interception, I'm talking about the bad guys intercepting my Bitcoins, either in sending and receiving. Now, let's suppose you're sending money to me. When you send money to me, how do you get the address to send that money? Well, presumably I get an address from my wallet, and I tell you somehow. And in that whole process, I could intercept, or I should say, the bad guy could intercept that process and swap out the correct address for one that he controls. So in the case of my Electrum wallet, when I'm looking at the screen, I mean, let's go through. How could interception happen when I'm, say, taking money out of my exchange? Well, for starters, I'm probably looking at a web browser to interact with my exchange. If the web browser was hacked, you can just intercept it there by swapping out silently the address I cut and paste into the exchange website. So the address may be correct, but what the exchange got was wrong. And thus, I withdraw, you know, $10,000, and the bad guys get all my Bitcoin. And in the other scenario of I have some Bitcoin and I send it to someone else, same situation. You know, let's suppose I'm instead buying an expensive plane ticket. You know, I'm on cheapair.com. I'm about to go pay, about to go spend $1,000 and I am looking at a web browser again. I'm looking at an address, and I cut and paste that into Electrum, or maybe I scan a QR code. Whatever it is, that address might not be what the vendor actually wanted me to go pay. It might be the bad guy, in which case they've intercepted my Bitcoins. They didn't take my private keys, but they still took the money because they were able to intercept that transmission. And finally, screw-ups. You know, you're looking at one right there. And this is sort of just the general case of, well, the software didn't really do what you wanted it to do. A famous example is actually from Mt. Gox many, many years ago, when their wallet software had a bug in it and sent quite a large amount of Bitcoin, I think on the order of tens of thousands of coins, to unspendable addresses. My understanding was the root cause was actually a Python problem where some string got put in place of a script or something like that, and essentially the script pub key, where the money was supposed to go, there was no way that you could satisfy that condition, and thus the Bitcoins could never be spent. They're still sitting on the blockchain to this day. And that kind of risk is essentially a software problem, essentially a software programming problem, and that really comes about poor review. In the case of Mt. Gox, I mean, how many people were looking at that code? Probably not very many. It wasn't open source, it was internal to their system. But these kind of mistakes happen, and it's worth considering. But theft, of course, is a big one. And another way to go put this is really about trust. We have this concept of trusted computing, which gets used as a buzzword in a lot of different contexts, but I think the simple meaning here is, well, is my computer trustworthy? Do I trust it to do what I want it to do? I intended to do something with my Bitcoin. Will that thing actually happen? And in my consulting, I often talk about this in terms of customer intent. I often consult for exchanges and other custody holders of other people's Bitcoin. And the key thing there is, did you act on your customer's intent correctly? Did you do what they expected to do? So let's look at a hardware wallet. And for this talk, I actually went out and bought a ledger. That's how it comes, sealed in a box. And essentially, this is a mini computer, and it's supposed to go connect to my existing computer. And if this is going to be valuable, I'm going to assume that my existing computer is compromised. All right, so somehow this thing has to go protect me. Well, first you might go ask, how do I know what's in there, right? Something that can go wrong is the hardware doesn't actually do what it claims to do. What if the bad guy intercepted in a shipment? And when you open it up, and I'll point out there's no security seals on this. There's no holograms, there's no nothing. And in fact, when you open it, you get this little notice. Did you notice there's no anti-tampering sticker on this box? Some cryptographic mechanism, check the integrity of your ledger's device, internal software, et cetera, et cetera, et cetera. So that's telling me it's okay that there's nothing to go and protect me directly against. All right, let's go trust this for a second. Let's open it up and let's see what it looks like. Oh, sorry, got a bit out of order there. So, and actually I should have pointed out, so here's our claim too. If you buy it from eBay, and you perform the testation fully, you're good to go. So, sounds good, I'll go buy that off eBay. And in my case, I actually bought mine in a kind of dodgy little store in Slovenia at the outskirts of town. So hopefully this all works. And here's the UX. So that's my laptop in the background, and that's my Trezor in the foreground. And in this case, I'm trying to go send the Trezor money. I've set it all up, and I'm trying to go send it money. And what it's doing is letting me verify the address on my computer and verify it on my ledger. Sounds all good? I now know that two things are true. But again, let's go back to the interception use case. Interception threat. Where did I enter in this address? Right? So I verified that the address is the same on two devices, but I still have to enter it somewhere. Chances are, in most flows, I'm going to enter it into my computer. maybe looking at web browser software on my computer, and that's how I'll be logged into my exchange when I'm buying Bitcoin. Obviously, the bad guys can just go swap it out in the web browser. So it's not clear to me this actually helped that much. It might help if we use a non-standard user flow. And I've actually told some of my clients to go do this. As an example, you can imagine an exchange where if you want to buy, $1 million Bitcoin, or $1 million worth of Bitcoin, they would call you up and verify the address twice. But I've nearly never seen this actually implemented. So in this case, it's not actually helping us. We can also think about, again, the reverse scenario. I'm buying something with my ledger. Again, where did the address get put in? It got put in a compromised device. And again, while we have two factors, we're still sending our money to the bad guy. It didn't actually go help us. Now, maybe it does help us in that we're not going to lose the money due to straight theft. The keys are supposed to be on that device, not on my computer. But, you got to ask, is that even really true? Well, what happens when we take it apart? And for the ledger, this is quite easy. The device, the back of it just pops right off. And in fact, it even works while it's taken apart, which should really go tell you something. The device itself isn't physically secure in the sense that what you're looking at, what you're interacting with, is not a physically secure enclosure. It's running just fine right now, and I was able to successfully put it back together again. And the attacker, of course, can do this too. And since the box isn't sealed, they can also put it back in the box and get a $100 shrink wrap machine to go and put the plastic cover back on. No big deal. Well, and what are we looking at here? You've got our USB port. Just to the left of it, that black thing is a non-secure microprocessor. And just to the left of that, at the sort of top of it, that's the secure chip. And then finally you get the screen, and there's two buttons. Well, what's the computer actually connecting to? It's not the secure microprocessor, it's the insecure one. And the secure element that is apparently proving integrity is not actually connected to anything directly. Also, what does it even matter? What I'm actually interacting with is not a secure piece of hardware, it's a screen. And we can see this a little more clearly if we look at the block diagram. USB host, insecure chip, secure chip, a screen, and some buttons. So what could I, the bad guy, do with this? Well, why don't I go break open some devices and, for instance, change the insecure chip to maybe compromise your computer over USB? I can certainly do this, assuming your computer is vulnerable, and lots of them are. And you're not going to notice. And the neat thing about this is, hang on a second, I know what type of user is going to use this device. I know it's going to be people who have Bitcoins. And that's telling me something very important. This might be worth my while, because I might actually make some money off this attack. Or, maybe I'll rewrite the firmware, and when you install it, I just make it intercept the seed, right? Because when you initialize a ledger, it displays the seed on the screen for you to go right down and back up. Definitely a good policy. You want to have a backup. But that means that an insecure thing, that insecure processor, had access to the seed. It can essentially take a capture of that and just store it and do whatever it wants with it. You had to interact with insecure hardware to do a secure thing. And maybe sometime I can go and exfiltrate that later. Maybe, again, I could sneak that off on the USB host, on the USB connection. There's lots of ways I could get a seed out. I could even use something in between where maybe there's a partial attack, which, say, runs a program, say, type, something into a web browser to get that seed out. So I've stolen the seed, yet I didn't have to compromise the secure element. And finally, of course, I can also be very clever with the takeover scenario. Let's suppose that I have an attack that can reliably compromise 1 in 10 computers. that your average ledger is hooked to. It's only 1 in 10, but it's 1 in 10. Well, why don't I go and make my custom firmware that I've installed on this insecure device, take over the computer, and then communicate back to go and acknowledge the fact that, hey, we've actually successfully compromised the device. 1 out of 10 times I'll succeed, and then I run the payload and do something special. But then 9 out of 10 times where that fails, well, you just treat it as a normal ledger. You run the normal code, it communicates back and forth with the secure elements, and that's that. Again, this is another possibility which I can go do, because once you've opened the device, once you've intercepted it, you can do what you want. In fact, why am I even bothering with this MCU at all? Why am I limiting myself to assuming that's what's actually in the hardware? Remember, I'm the bad guy. I went to the effort of intercepting packages in transit, so why don't I just get normal ledgers, unsolder the secure element, and then solder it onto a new design of my making. If I do this kind of attack on a reasonably big scale, I can put whatever hardware I want in it. And again, that gets back to our Doom example. Once you open up the back, you can put whatever you want in there. You're already in a scenario where you're compromised. And finally, let's just talk about software quality. So, if I run, say, a wallet on Bitcoin Core, I've got tons and tons of dedicated programmers looking for bugs. They're not perfect. I mean, there was this minor issue where I could inflate Bitcoins a few weeks ago, but it eventually did get caught. On the other hand, with something like Ledger, how many people are actually looking at that code? It's not quite open source. You can kind of see the code, but there isn't really a community around this. There aren't a group of people developing it. So you kind of got to wonder. And in this case, this is actually very interesting. So here, Ledger's build system was apparently compromised. Or maybe it was a mistake, we're not quite sure. But somehow, a version of the Ledger wallet software got pushed, which replaced all addresses with a single fixed address. In this case, the Ethereum part of the wallet. Now, if I were an attacker, this sounds like a very useful attack. Swap out the address with something I control and just take whatever money I can. So you really got to ask yourself, how did this happen? How did the processes fail this badly? I've also heard of other examples where in different wallets in Ledger, they brought signing keys to things like DEF CON and other hacker conferences. And I'll admit I've kind of anonymized exactly the scenario a bit, because I'll let the person who told me this remain anonymous, but this is the kind of issue that goes and happens. And again, this happens because we're not using mainstream stuff that's well reviewed by a lot of people. You also got to talk about the programming practices on these devices. A lot of the devices, because they're relatively limited, are still stuck on older languages like C to actually write the code in. And I'd hope in this audience we know that writing new stuff in C is probably not the best idea. I think this particular problem is fixable, but we're not really at the point yet where we're getting good quality on all the wallets out there. Some are better than others. I hear Tracer, as an example, actually runs Python in most of it. Well, I wouldn't necessarily even call Python a great language for writing security critical software. But it definitely is an issue, and you definitely have fewer eyes on it. So finally, what are the alternatives? And I thought Ryan Lackey actually had a really good point here, which is really about supply chain security. And you've probably heard about the recent alleged Supermicro attack, where a little grain of rice thing was allegedly implanted in motherboards. And frankly, based on what I know, I'm a little skeptical of that attack. I'm not sure Bloomberg got the story right, but it certainly is a plausible attack. And things similar to this have happened. We know for a fact that the NSA has backdoored Cisco routers because we have the wonderful photos of them opening up the boxes. And we know that Supermicro has shipped servers with terrible firmware that mysteriously had a downgraded version. Who knows why that's happening? But the key thing from our point of view is that we can go hide amongst the crowd. So if you're using hardware that most end users won't be a good compromised target, it provides much less incentives for the bad guys to compromise your supply chain. Well, what does this mean? Well, imagine if instead of buying a ledger, I go buy a Raspberry Pi. All right, what's your average user on Raspberry Pi? It's probably a 10-year-old learning programming for the first time. They don't exactly have a lot of lunch money to go steal. I mean, this day and age, maybe they'll be running Lightning on it and running a Bitcoin node, but they're probably not going to have much money still. It's not a good target. Or for that matter, if I have a random laptop. Which means, why not use wallets that are actually based on custom software on off-the-shelf hardware? Tails is a good example of this, where Tails is a Linux distribution where you can download it, and amongst other things, such as anonymous web browsing, you get an Electrum Bitcoin wallet. If I use Tails, once I get that clean USB disk, chances are everything else will be clean, and the bad guys won't have any opportunity to take over my supply chain. Similarly, while there's a lot of stuff that went wrong, I think with Zcash trusted setup, something I think we did do really well was the hardware we used was just laptops that we went and bought at random computer stores. There's no real opportunity for compromise there. You walk into a store and just buy something. What's the NSA going to be stucking agents in every store to go quickly swap out hardware? No. That's not likely to happen. Of course, if you're buying a lot of hardware, this is a different story. The likes of Apple have a very hard time buying a data center worth of hardware without revealing who they are. But for us, it's easy. And with that, thank you.
HackIT. Exploit blockchain.